Hey there, Pre-Calc kids. Today we're looking at 3.12 more stuff. Alright, sum and difference formulas. They do come up. It's not a hyper common thing to see, but they do happen. So if something's on the unit circle, we can do the exact answer, right? Without much thought, because we have it memorized now, right? Yeah, Mr. Holger, yeah, we do. Sometimes we don't. But we should. So these formulas only come into play. I'll give you a hint, I remember them too. So like for sine, it's sine, cosine, cosine, sine. So they each get whatever, but it's plus, plus. And sine is minus, minus. Where cosine, if you have a plus here, you have a minus here. It's opposite. It's opposite. Okay? Kind of like the even odd stuff. Sine keeps the sign, cosine changes the sign. The other thing that changes is cosine, cosine on one side of these formulas, if you want to look for things to memorize. We'll do something with it. We'll see if it helps us out. Okay? Okay. So there's that. Now my double angle formula did come up on that last practice test we took, but I won't talk too much about Mr. Williger. And with the double angle formula, calm down. Wait, you're setting up the mic? It hasn't. All right, that was scary. It has been working. So sine of 2 theta is the same thing as 2 times sine of u times cosine of u. Now cosine of 2 theta actually has one identity and 2 corollaries to it. This is the big one we use a lot. If you want, I can prove to you why these other ones exist, but I'm not going to right now. Save some time. All right, let's do example 7. Calm your body. Chimney crickets. All right, in example 7, we have to find this thing. And we don't know. We don't have 5 pi over 12 on our unit circle. But we do have pi over 6 and pi over 4. That when you add them together, you get 5 pi over 12. So I'm going to use my formula from before. My sine of, instead of doing sine of 5 pi over 12, I'm going to do sine of pi over 6 plus pi over 4 because they're the same thing. And then I'm going to go use my formula. All right, so according to my addition rule, there's a mouse doing weird stuff. All right, according to my addition rule, if I'm adding my sines, that's the same thing as sine, cosine, keep the plus, cosine, sine. Like when I go back and look at my formula. So I'm going to do sine of pi over 6, cosine of pi over 4, cosine of pi over 6, sine of pi over 4. So everything gets signed once, everything gets cosigned once, and you add. Alright? So now these are on my unit circle. If you want to watch some of my other videos, I have some videos that go way more into detail on this. This one is very quick. I don't know if it's going to come up what. I could be wrong. So, sine of pi over 6 is 1/2. Cosine of pi over 4 is root 2 over 2. Cosine of pi over 6 is root 3 over 2. And sine of pi over 4 is root 2 over 2. Right? So this becomes root 2 over 4, just multiplying fractions, plus 3 times 2 is 6 over 4. So I get square root 2 plus square root of 6 all over 4. No calculator needed for this guy. Okay? All right, let's do another one. All right, let's do this sum of this one. So I can rewrite this as cosine of pi over 4 plus pi over 3. Because they told me right here. I also could have done, no, I could have done that. I could have also done a -1 too, but I usually stay with the pluses. So now according to that formula, it's cosine, sine, sine. And then this would be a minus because it's opposite my plus. So I'm going to do pi over 4, pi over 3, pi over 4, pi over 3. Okay? All right. So, cosine of pi over 4 is root 2 over 2. Pi over 3 is 1/2. Minus sine of pi over 4 is root 2 over 2. And sine of pi over 3 is root 3 over 2. So this is root 2 over 4 minus root 6 over 4, which they have the same common denominator, so I can do root 2 minus root 6 over 4. Too easy. Okay. Let's verify this identity. I lied. I'm going to do 9 too. Let's prove using our double or our sum and difference formulas that this is the same as cosine. And we know shifting it over pi over 2 is the same thing, whatever. We know this, but let's prove it. So now it's a sine over here, right? So I'm going to do, whenever I do my sine one, it's going to be sine, cosine, cosine, sine. Keep the sine with sine, and then plug in my stuff. Pi over 2, x, pi over 2, x. All right. Sine of pi over 2 is 1. That remains cosine of x. Minus, what's cosine of pi over 2? 0. Times sine of x. So this side goes away, so I'm left with cosine of x, which is what my right side equals. There. I just proved the identity for y'all. Y'all didn't think I could do it, but I did it. All right. Well, I hope you enjoyed. Short one today. Have a good life.